Homework number one, I made an answer video for your viewing pleasure. So first off, this is the right data set, right? Just download it from our Moodle. First variable we're going to do is age, and we want the measures of central tendency. We're going to use the descriptives function, switching over, analyze, descriptives. Again, we're working with age. Here's a trick. You click on this box, anyone in here, you right-click, you could change it to the variable names, okay? I'll say that again. Right-click on any of these. You could switch it to the label names or the variable names. I prefer the variable names. So click age over. And then you got to tell the computer which statistics you want. Don't want the sum, but I want practically everything else. Kurtosis, skewness, don't need anything in this box down here. You're going to click OK. And we're going to save these as standardized variables. What that means is we're going to find the mean of age. We're going to subtract each individual age from the mean of age and divide it by the standard deviation of the age. And I'll show you that in a second. Hold on. Here's your descriptives. I'm going to go ahead and cut and paste those into our Microsoft Word. Please hold. All right, to cut and paste, you click the box until the outline becomes black. You see that? You right-click, go to copy, switch back over to your Microsoft Word document. Where are you? There you are. And wherever you want to put it, just put it right there. Right-click, paste. And again, the box is too big. You'll notice that it slides off. It's too big for the Microsoft Outlook. You click that little box here, right-click. Auto fit. Hold on, let me move it up a little bit. Make sure it's highlighted. The whole thing's gray. Right click, auto fit to window. Kabam. And it fits into the window. Nice and neat. I love that function. All right, so there's all your means and standard deviations, etc., etc. So now we're going to look at the normality and outliers. Hold on. Back to the data sheet. Okay, let's move this over a little bit. So we're going to check the normality for age. You're going to go to Analyze, Descriptive Statistics, Explore, and we're going to kick age over, right-click, change it to age. It doesn't have to, you don't have to do that, but I'm going to put that in the dependent list, and then I'm going to tell the computer what I want from that list of data that we've named age. Descriptives, sure, we already have those. I don't care, we get them again. Plots, this is where I want this time. Unclick the stem and leaf. I want a histogram, right? A histogram is the easiest way to look to see if a data set is in fact normal. And then we're going to click this. It's going to give us the normality test known as the Kolmogorov-Smirnov test. I can't pronounce that. Nothing under options. Click OK. And it should come up on our output sheet. There's our normality test right there. And you'll notice that since the significance is less than 0.05, that means we violated normality. So a normal data set, here, let's pull up this histogram. You see that? It's skewed. Let me pull up a picture of what a normal data set should look like. So a normal data set, a normal frequency distribution should look like kind of like a bell curve, right? This one's kind of high, which means it's probably what we call leptokurtotic, but it's the symmetry we're looking for now. And there's one in the middle and there's one kind of low. But this is what a normal distribution looks like. Ours isn't very normal. It's skewed to the right-hand side. This is what we call a positive skew. So the data is not normal. So we're going to go ahead and cut and paste the histogram. Click on it until it's black. The outline is black. And then scroll up to the Smirnov test of normality. And then hit Control, and then click the Smirnov box. You'll notice they're both highlighted. So you're going to right-click, copy, back to the Microsoft document, and wherever you want to put it, you're going to right-click and paste. And there it is. There is your histogram that says that the data is not normal, and there is the backup Smirnov test that says the same thing, the data is not normal. So let's look for outliers now. Hold on. So outliers, remember when we checked that box under descriptives, check the box to save the variable as a standardized data set, we should have a new data set where the data has been standardized. Let's go back to the regular data set. Hold on. And then here's the new variable, right? These are all Z-scores now. So let me pull up a Z-score formula to show you what that is. That's the Z-score. Z stands for standardized version, value, whatever you want to call it. So the X is the individual data point. The mu, that's a Greek letter U, mu, is the population mean, and the standard deviation down there, that little baby sigma, is the standard deviation of the data. So let's say that the average age is 35. That would be the mu, and the standard deviation is 5. I'm just making this stuff up. And somebody was 40 years old. So you would do 40 minus the mean of 35 is 5, divided by the standard deviation is 5 divided by 5 is 1. So the Z-score for somebody that was 40 years old would be 1. What that means is he is 1 standard deviation above the mean. So back to our data set. I'm going to right-click. I'm going to put them in descending order. That means they start from the big ones to the bottom. So you got now every age is turned into a Z-score, okay? So how do you tell which one of these are the Z-scores are outliers or not? Well, that's easy. Hold on. There's a very important rule in statistics. It's called the empirical rule, or the 68, 95, 99.7% rule. I like the empirical rule better because it's easier. But what it basically says is that in a normal data set, that 68% of the data should lie between the mean of the data plus or minus 1 standard deviation. 95% of the data should fall between the mean plus or minus 2 standard deviations. And then practically all of it should land between plus or minus 3 standard deviations. But we're only interested in the 2 standard deviations. So look, 95% of the data should fall within 2 standard deviations above the mean, 2 standard deviations below the mean. So anything outside of that is considered an outlier, okay? And this is just a rule of thumb. The real number is 1.96 standard deviations, not 2. But since 1.96 and the number 2 are so close together, you're only talking about 4 100ths difference. You can go ahead and use 2 as your cutoff. So let's get back to our data set. So that means any Z-score greater than 2 or less than negative 2 would be considered an outlier. So I'm going to highlight all the outliers. And there's a lot of them. Hold on. All right, so I'm just going to go to 2. So in other words, you have 102 outliers because they're old. In fact, anybody over 80 is considered an outlier. So let's go to the other end. Let's right-click, and this time we'll do sort ascending. And there's nobody below negative 2, so we don't have any youngsters in there. So again, all the outliers are basically anybody over 80. Let's fix that again. Got it? And that's how you identify an outlier. So let's put that on our Microsoft document sheet, and we're done with age, right? So outlier for age is anybody that's basically over 80 because their Z-scores were greater than 2. All right, we're going to redo the thing for education. I'm going to do it real fast, so just kind of hold on. All right, you're going to go to Analyze, Descriptives, out with the age, get out of there, you, in with the edu. Everything should be basically, the boxes you click for the first one should be there for the second one, and they are. We're going to click Continue. All right, so that answers our normality. I'm sorry, our descriptives, our mean, medium, and mode, and standard deviation. Right, there's that one. So now I'm going to go and check the normality. Analyze. Descriptives explore. Out with the age. In with the educ. And again, whatever you clicked in these side boxes before should still be there. Don't really care anything about that. But we do want a histogram and a normality. Click Continue. Don't care about anything else. Click OK. And that's going to give us our normality. Oh, my goodness gracious. That is not normal. And our Smirnoff test, that's good. And hold on, I don't think I checked that box. I'll just do it again. For analyze descriptives. Get back in there, you. And oh yes, I did. So let's check our data sheet to see if we did get a Z-score for education, and there it is right there. So I'm going to right click, put them in descending order. And again, so any Z-score that's over 2 or less than -2 is considered an outlier. So I'm just going to go ahead and see where the outliers stop. Hold on. So it looks for education. It looks like for education, anybody with 20 years of education or above is an outlier for education. I'm going to right click, put them in ascending order, and you'll notice that you got some missing data here, right? There's 12 pieces of missing data. So you don't know what to do with those, but I do see some outliers on the other end, on the negative end. So again, anything less than -2, let me pull that up, see what that is. Yeah. There it is right there. So anybody with 7 years of education or less are also considered outliers. So to wrap this one up is anybody with 20 years above is an outlier. Anybody with 7 or below is an outlier. And that is it. I hope you guys learned. Normality, very important. Z-scores, very important. MGZ, out.